Hello, everyone. Welcome to day two of TestMu Conference 2023. We are starting just a few minutes early, but I hope you all had the time to grab a cup of coffee and start your day. So I hope you all are as excited about today as I am. We had a pretty great lineup for you today as well. People who don't know me, I am Mudit Singh, founding team member at Landmark Test, and I lead the marketing here. And I'll be host for you for this session. So we had a pretty great day one, and I promise you that the day two is going to be pretty as exciting as well. And we already had a very great start for the day two as well. So with the Indian Space Research Organization making history by doing a successful soft landing on the south pole of the moon just a few hours ago. So let's start off by congratulating ISRO Chandrayaan 3 team and every space exploration enthusiast. As you can see from here, we are that one of those as well. So congratulations, everyone. And we are pretty excited about this here at Amethyst as well. So now coming back to TestMu, we started this conference with the aim of bringing greatest thought leaders in the space of testing and development together, building an event that promotes discussion on innovations in testing. And keeping that same spirit in mind, I'm honored to welcome our keynote speaker, Mr. Mahesh Venkataraman, Managing Director, Cloud First at Accenture, who's going to talk about expanding the horizons of innovation in testing. So Mr. Mahesh has over 3 decades of experience in the field of technology management, service management, business management. He holds about 12 patents and has been a frequent speaker across international conferences and also a visiting faculty member. Now, before we get started, few ground rules. You will see there's a Q&A section in the right side. So if you have any questions, feel free to add it over there. And at the end of the sessions, we'll try to take few of them. All these sessions will be recorded, so you will be able to watch them in the replay above, or we'll be hosting them on our YouTube channel at the end of the week, so you can check that out over there. Now, with that out of the way, please welcome Mahesh. Mahesh, sir, the stage is all yours.
Yeah, thanks, Madit. You can hear me, you can see my screen, you can see
Yes,
me.
sir. Yep, definitely.
Okay, excellent, excellent. So, so title is expanding the horizon of innovation. No, why horizon? Because horizon is an illusion, right? As you progress forward confidently, the horizon disappears or it extends beyond. So any boundaries that we've set for ourselves in the realm of any field is an illusion. All you have to do is keep walking along, go forward, and the boundary disappears. So let's look at how do we expand these boundaries, which are actually imaginary. Now, the last couple of decades, innovation in testing has been synonymous with automation. And of course, now AI and Gen AI. Can we think of innovation and testing beyond automation, but with automation as a strong foundation? Let's look at it. Now, when I ask you, if I ask you, what are those most innovative companies, all these companies will come to your mind. Apple is one such example. What differentiates Apple from others? Apple has redefined the whole ownership of mobile phone. Mobile phone is no longer a utilitarian object. It is a lifestyle product. It has redefined it and redesigned the product and repositioned it, right? Redesigned the whole innovative. It's got an ecosystem. Many of us love Apple. Now, innovation in the way that I define it is all about redefine, redesign, and reposition. Now, how do we do this in the realm of testing? Now, just a quick, context. We have to balance logic and creativity when we want to innovate. Critical thinking, logical thinking on one side, imagination and lateral thinking. If you have read de Bono's concept on lateral thinking, on the critical thinking, you have always your judgmental. In the imagination and lateral thinking, you open up ideas, you suspend judgment. So we have to balance these two. Let's see how to do it. Before we go into innovation, let's look at some process challenges today. Now, all our stakeholders, most of the stakeholders keep saying we are doing too much testing, automation is not effective, too many invalid bugs, we cannot reproduce the bugs, no value from testing. Now, a survey that we conducted internally, we found that 30% on an average of the test suite is defunct, means they don't contribute to defect discovery. mean, they have never failed since the time they have been created. Now, coming to automation, we found on an average 40% of the automation, so-called automation scripts, they need babysitting, they need manual intervention. And 25% on an average of the defects that are found are invalid based on test data issues or environmental issues. So this is the process challenge today we see testing. Coming to production failures, what we found is 80% of the production failures are actually related to structural issues. Structural in the sense architectural, infrastructure related, very less on 20% on functionality. But whereas our focus in testing is mostly functional, and 50% of those production issues are non-reproducible. Developers cannot reproduce those incidents. And 80% of those incidents, when we do analysis, did not have any associated test case with it, right? And then they keep recurring, keeping occurring again and again. So much for testing process and the production failure. So despite a lot of testing, a lot of automation, we still have serious issues today. Now, coming to the challenges in modern software delivery that we are all facing as quality engineers and testers. Number one, Agile focuses a lot on feature velocity and rapidity. It is all about being agile. But then the architecture tends to degrade over time because, like a building, you keep adding more and more floors, the superstructure degrades. Similarly, in complex architectures, as we add more and more features, the superstructure architecture tends to degrade, and developers don't have any way of knowing what decisions they have taken before have to be revisited. Now, what are the imperatives for testing here? We will see it later. Second challenge, complexity. This is the microservices model of Amazon and Netflix. Thousands of microservices. It's called the hairball model, right? Now, how do we ensure they all are working, in terms of all aspects of quality, right? Third is cloud. Now, cloud is distributed. Now, when we say distributed, hundreds and thousands of components come together and form the cloud application ecosystem or the workload. Now, the complexity of interactions is enormous. You see this animation here. On the left-hand side is the whole front end and the messages, the API calls, they go all the way to the back end. And at any point, you will not know where the request is unless you are actually digging into the application monitoring tool. And what happens in cloud is, it's called unforeseen emergent behavior, means the final behavior is unforeseen. You cannot predict it. And cloud application workloads tend to fail unpredictably. And many of these failures are asymptomatic. You will not know for a long time until the failure, internal failure, bubbles up to a UI where the client or the user is able to detect it. And these failure modes are based on so many factors, exception handling problems, error recovery problems, resource overload. The very characteristics of cloud that make cloud a business value, the same characteristics give rise to risk if the cloud application is not architected properly. Now, what are the imperatives again from a cloud perspective? Now, the fourth is AI. Now, we are talking about a lot of these applications are infused by AI and Gen AI. In the lower two stages of the application, continuum, it is fairly predictable. So your test cases can be written in a very deterministic manner. Now, as we move towards data intelligence driven behavior, the knowledge and reasoning behavior, which is going to be the case as we move to the Gen AI infused applications, your test cases will not be able to detect problems because the application behavior is non-deterministic. Given the same set of inputs, based on various conditions of usage and the time, application will behave very differently based on the context. So the test cases, the whole concept of I will give test data, I'll give test inputs, check out the test, validate the behavior, that is not going to work anymore. Now, testing involves the current modern architectures, modern software delivery testing involves taking decisions under uncertainty, ambiguity, decisions of what to test, how this application is going to be, the workload is going to be used under field conditions, in what ways is this application ecosystem going to fail? It's a world of VUCA out there. VUCA means volatility, uncertainty, complexity, and ambiguity. Now, testing is becoming mission impossible. For example, your mission, if you choose to accept it, is a testing and assuring a complex algorithmic trading platform. Limited time, limited resources, skeletal documentation, upstream quality not guaranteed, but requirements turned guaranteed. Now, we are all Ethan Hunts. Now, what are the qualities of Ethan Hunt? Ethan Hunt is very brave. Ethan Hunt adapts the tactics based on the context and the situation. Ethan Hunt doesn't care about what people think about him. And Ethan Hunt ensures that the goal is achieved. As testers, we have to be goal oriented. We have to be extremely brave and courageous. We have to adapt our strategies and tools and techniques to suit the application landscape, the delivery landscape. And last is, we cannot be in a popularity context. We should not be really worrying about what people think about us, because we are here to give the good, both the good and the bad news. Now, how do we apply innovation techniques in testing? Now that we have a high, overview of the challenges, right? Now, I'm going to be talking about 4 techniques that I personally have found very useful. First is the jobs to be done concept by Clayton Christensen. The Clayton Christensen, he is the author of a very famous book called Innovator's Dilemma. Second is cross-industry analogy. How do we learn from other industries and apply analogy and metaphors in driving innovation? Third is how do we provoke our mind? It's called de Bono's lateral thinking. I have picked up one idea from that technique, idea reversal. Fourth is biomimetics. How do we learn from nature? Because nature is very innovative. How do we apply nature's innovation into testing? Now, let's talk about first jobs to be done. Some examples here, right? Left is a milkshake. What a popular fast food takeaway restaurant found, they wanted to improve their milkshake sales. They tried to add more and more flavors, better taste. They found that was not actually contributing to sales improvement. What they found was that the buyers of milkshake, early morning buyers, were actually office goers who were driving to work. So what they wanted was not a hunger satisfaction, but something they can hold on to when they were driving to work. So because they were getting bored, their job to be done concept, which is what is that they want achieved in that purchase, is something that they can hold on to and drink over the next half an hour or 1 hour. So by simply adding to the flavors, they were not able to improve the sales. So by adding better packaging and consistency, they were able to improve the sales. Now, coming to cafes, we all know that we all go and have meet our friends in cafes. How the cafe today is redesigned or redefined as a social setting. It's no longer a coffee, tea, hunger satisfaction, right? So the way they have redefined cafe to be a social setting, they redesign the space, they reposition cafes, right? Now, how do we apply in the realm of testing? Now, what is the job to be done? What does customer want today from testing? Is testing, after all, is a verb. Now, what is the outcome in testing, right? Now, we can say the answer to the output of testing is reports. Now, our stakeholders are saying those reports are pass-fail reports. They are not adding to my insights. So what we need to do is, from the jobs to be done concept, we have to provide actionable insights that are actionable, that a program manager, a CIO, or a test manager, or a development manager, or an architect can actually apply and improve quality, and also faster go to live pathway. The second is cross-industry analogy. A couple of examples, right? The idea of a foldable pram was picked up from aircraft landing gear. Similarly, the idea of a crumpleable, wrinkle-free map, which you could just crumple, put that into your pocket, a big map, was picked up from crumpleable handkerchief. So every industry has innovated by looking at another industry and applying some of those analogies in the current industry. Now, what about testing? A lot to learn from cross-industry in the realm of testing. Let's take, the concept of, say, treasure hunt. Now, what do we do in testing is we actually find defects. Now, how do we optimize? How do we maximize defect yield? Now you can apply defect search optimization techniques based on what we do in treasure hunts or in search and rescue mission, wherein there is a search and rescue activity and they actually optimize using scientific techniques so that they are able to find the victims in a shortest possible time. Similarly, like an army marching forward, trying to detect landmines, right? They cannot go all over the place. They cannot do random check. They have to go by an algorithm. So the second idea we get from cross industry is how do we apply defect search optimization techniques? Use of AI is not the point here. How do we use AI, ML, and Gen AI to optimize our search to maximize defect yield? Second and third example is similar to security agencies. What they are doing is like a police or a central intelligence agency. They are actually collecting a lot of data and applying analytics, and they predict where the law and order problem could be in what area at what time. And whenever there's a problem, they do a causal analysis. So they do a predictive intelligence, they have a causal intelligence, and they have a generative intelligence, which is primarily looking for patterns and connections. Similarly, as testers, we cannot just be limited to testing. We have to provide quality intelligence as to how prediction intelligence, causal intelligence, and patterns and discovery intelligence. And similar to the aircraft cockpit and a weather report, we cannot stop at, it is not enough that we stop at a dashboard with all the graphs and charts. We need to provide guidance visualization, which are interactive, where a test manager or an architect or a CIO can interact and get some actionable insights. So if you look at it, actionable insights, quality intelligence, and guidance visualizations are all related, derived from various sources of innovation. Now, what is a torch? A torch is a torch. Now, suppose you are going into a cave, and what you do, you have a torch and there are snakes, and what do you do? Assume that torch has two different adjustments. One is the beam, width. Either you can choose a narrow beam or a broad beam, or you can choose the intensity. Similarly, a test case is like a torch shining light on the test case. So can we infuse more intelligence into a test case based on the risk? We call it risk adaptive intelligent test cases. Based on the risk perception, we either improve the rigor of the test case or we reduce the rigor based on the risk perception. So a test case can become more intelligent in terms of risk adaptation. Now, what about learning from this treadmill? This person is undergoing a simulation. And let us assume this person is being selected or being evaluated for army or defense forces. There are stress simulations, there are fault simulations, based on the response, the selection happens. So now you have the simulation, then you have the probes in various parts of the body. You already have modeled the body, various reactions of the body. Based on this, we can pick up the idea of how do we apply modeling, simulations, and observability driven testing. Modeling is about failure modeling. Now, simulation is how do we simulate the fault, the load, and security threats and various field conditions that we have gathered from, say, log mining, and apply into our testing strategies, and then use observability and monitoring tools to gain insights. Again, the number six will reinforce the other points. Now, let's come to provocation. Provocation is primarily, provoking your mind to go out of the box. When we do our job, we tend to go a beaten path. For example, somebody would have said, train without wheels, and the idea of magnetic levitation would have come, maglev trains. Somebody would have said, let's encourage ticketless travel. The e-ticket would have come, right? Codeless test automation, low code, no code. So where the idea reversal happened and the idea got forwarded, we moved forward of the idea and then developed the idea, and then the final innovation came to the picture. Now, how do we apply this in testing? Let's take an example. Today's status quo is test cases test the system. Now everybody will agree that test cases are required. Now we provoke. No test cases will be written. This is crazy. How do we ensure quality without test cases? Then we move forward. We cannot be stopping here. We say system will generate the test cases. Okay, this is okay, but how do you ensure system generated test cases? Then you brainstorm, then come with the idea. Log mining. Logs can be mined, the production usage can be understood, the behavior can be understood, and you can generate and improve regression test cases. So you can have this idea of system generated automation. Now, all these 7 ideas are better. They are actually, now we are in a position to apply these techniques better because of Gen AI. Now let's look at biomimetics. Biomimetics is a learning from nature. Now the Velcro idea came from the inventor saw that this thorny seeds got embedded in his dog's skin, and then you could pluck it out, but it stuck, and you could pluck it out. So Velcro idea came from here. Then this question of deep neural networks and deep learning idea was borrowed from the brain. The idea of how the neurons in our brain get fired when we recognize a person or a lion or a cat or any familiar thing. The neurons, they get fired in a certain order or intensity. Same idea got picked up in neural networks. Now, how do we apply this in testing? Interesting idea of ant colony optimization. Now look at this ant here. There is this colony here, and one ant starts to move towards the food. It's trying to search for the food, and it finds the food. It takes a pathway. Now ants, they release something called pheromones. It's a hormone that has strong smell, which other ants can smell and follow. So some of these ants start to follow this. Now let us take one ant that picks up a different path and reaches the food. Now the pheromone in this path, they stay longer because it's a shorter path. So over a period of time, ants tend to find the shortest pathway to food. So it's not very complex. It's very simple, but collectively it creates a very sophisticated outcome. Similarly, swarm. Now you look at the swarm intelligence. The birds, they are not programmed to be swarm intelligent. They're a very simple set of behaviors based on the communication with the neighbors. Now, how do we pick up this? We can get the idea of swarm intelligent test suite, wherein the test cases communicate with each other. And for example, if a test case fails, that test case can communicate the information about the failure to a related set of test cases, and test cases can sequence. They can optimize the sequences to maximize defect search. They can be run in parallel, and all the test cases can be communicated with each other. They can communicate with each other, what we call the swarm intelligent test suite. Now we have 2 kinds of intelligence in the test suite: risk adaptive intelligent test suite, which is individual, then the swarm intelligent test suite. Now, so what happens is, now the test case suddenly has become, much more than a test case. A test case is no longer a test case. It's a means of monitoring, means of diagnosis. It's a means of optimizing search. It's a means of modeling and simulation. It's a means of mining and prognosis and diagnosis. Now, what does it all this take us to? If you put all this together into a cogent framework, now what is the objective of testing function? Testing function cannot remain testing anymore. Testing has to evolve into a life cycle quality advisory, which means testing has to provide, based on analytics, AI and Gen AI, quality intelligence. Quality intelligence, not just product quality, process quality, structural quality, how the upstream process events, how the upstream process actions are actually leading to downstream quality, and continuous predictions. Just like driving a car or a pilot flying the aircraft, there's a continuous feed forward, which is look ahead, predict, fine tune the process, ensure the product quality is as per the norms, and then a feedback cycle, which is your learn from what happened and fine tune the process quality, structural quality, and product quality. We cannot remain at just functional and non-functional quality. We'll have to do a continuous analysis. And then, of course, quality guidance visualizations. It is not enough that we stick to only dashboards and graphs and charts. They are required, absolutely. But many of those charts are rear view mirror charts, means they actually talk about what really happened yesterday. What we need is a continuous guidance for quality engineers, for architects, for CIOs, and all the stakeholders. Second is optimization. Now, we said we have to apply optimization techniques, statistical AI, Gen AI, machine learning to optimize and maximize defect yield per dollar spent. And then we said that individual test cases, we have to infuse more and more intelligence, risk adaptive, based on the rigor required. It adapts and ensures that, like a torch, ensures the breadth or intensity. And second, swarm intelligence, how the test cases can communicate with each other and create a swarm test suite so that you're able to detect, predict, and detect quality very quickly. Automation. Now, automation today is specification generated automation, right? You look at the requirements and then you generate automation. We can complement it by having system generated automatically generated automation by use of Gen AI. The last is very important, is we have to infuse more and more modeling. When we say modeling failures, modeling degradation, modeling performance problems, modeling resiliency issues, modeling security issues, and modeling scalability issues. Modeling and simulate this during testing, not just infuse some test data into the system and check for functionality. Apply chaos engineering. And more important is, many of you would know observability is a buzzword nowadays. We have to infuse observability into our testing and integrate performance, resilience, security, scalability into one single whole, right? So all this is going to contribute to lifecycle quality advisory. It's not enough that we do testing and testing. Testing is not testing anymore. Now, how can Lambda Test and Accenture, what are we doing to drive our partnership? We are very impressed with Lambda Test because they're pretty innovative in the way they have come out with the products. While there are so many tools today, every tool is competing with each other in the test automation space. They kind of innovated and said, we will do orchestration, like a Zubin Mehta orchestra, right? And ensure that all these tools are brought together under a common platform. And another idea is just in time. They're able to ensure testers and testing teams are able to get just in time environment, which is amazing. And between Accenture and Lambda Test, we are actually collaborating on the roadmap. We're collaborating how to provide the best to our customers. And more important, how do we innovate? How do we mature the industry as a whole, not just Lambda Test and Accenture? Of course, customer benefits, Lambda Test and Accenture benefit from their business growth. More important is how the entire testing community can benefit through sharing of knowledge, like conference such as this. So some of this visualization, I thought if you have time, we have, I think, around 5 minutes. So here, this is again, as you see, it is not just some kind of a graph. It is visualization that helps you understand how the upstream process, how the upstream actions and events are actually influencing downstream quality. And then we have started using many of these, what we call the quality intelligence, interactive guidance visualizations, right? Many of these techniques, we use scatter plots, we use radar diagrams, we use box plots, moving average, heat maps, knowledge graphs. This is what we need today for us to satisfy and ensure our customers are successful. Now, people are telling that there's all this Gen AI is going to remove the need for testers. If you look at this, right from the elephant to a CNC machine to an aircraft cockpit and a sewing machine, the human is the center. It is very important to put the human in the loop to ensure these technologies actually bring about outcomes. The human being will never go out of fashion. Now, coming to the career streams, I think, there is so much to be done based on what I just spoke about. It's not going to be just, binary, automation and manual. We have opportunity to specialize the business process, AI, ML, data analytics driven testing, functional test automation, orchestration, the way the Lambda test. It is important to understand how this orchestration can be put to best use. Architecture engineering, performance engineering, resiliency engineering, security, scalability engineering, and of course, how to test infrastructure as code, right? So the new mindset is all about, we have to build on the old. Rather than pass fail, we have to talk about evaluation and assessment, hypothesis, modeling, simulation, optimization, perturbations, life cycle, quality intelligence, and interactive guidance visualizations. Why I'm throwing these words is the words are very powerful. They create imagination in your mind and give you the momentum and the impetus to improve. Now, that brings me to the end of this presentation. I'll be happy to take questions. Udit, over to you. Do we have time for questions?
Hey, Mahesh. Yeah, we have few minutes. We can take questions. But first of all, your presentation was so well organized that nearly 90% of the questions we have in the side are pretty much answered. I'll say question related to career was there, question related to which are the most emerging technologies. So that was covered in our AI slide. One question that I feel is pretty important here. This is related to the process management inside an organization. Let me show it on stage. So we have seen that, yeah, we have been talking about innovation techniques, but what to do when there's a specific code of conduct or let's say specific way of doing things in an organization, but you still want to innovate.
Yeah, see, this is actually I would say, a management or employeeship problem, right? Now, organizations have to come up with a set process to ensure there is uniformity. My suggestion, see, I have been in innovation, most of the last 10, 15 years of my career. I think it is important for us to be, as a person, I would do a lot of research and build my narrative and do a lot of experimentation, ensure that, for example, swarm test intelligence, right? Or, risk adaptive test intelligence. I have to do a lot of work before I present this to the customer. I have to have prototype. I need to have a team. We need to work. You have to build like-minded people, networks, prototype. First, show it works in small scale. Then, and then take it to one client. Even if one client likes it, I can tell you 100% your management will like it. So research, narrative building, a lot of hard work in piloting, working with partners. For example, for me, Lambda tests and other partners are very important. We can't do innovation alone. So we have to learn to innovate in teams, in groups, in partners, internal, external. So a lot of networking we have to do. Then show the pilot, show it to the customer, make the customer happy. Then the world is yours.
Awesome. I think we are pretty much hitting the time. So, Mahesh, first of all, thank you for being the best product ambassadors we can have here at Lambda Test, and also taking the time out, walking us through your pretty important insights that we had. I'll say that these are a condensation of 30 years of experience. Got to learn pretty much a lot of things in just last 30 minutes. We are pretty much hitting the time. So everyone, there's a next session. It's gonna happen within a minute. It's a very great panel discussion. I'm quite sure you guys will be enjoying it. All the questions that have been asked, will be answering them as well. We have a community, Lamitus community thread that is going to go live within few minutes. And we'll be posting these questions and answers to them over there as well. So feel free to check out.
Yeah,
And
feel free to also, send me an email, and I'll be happy to get into a discussion with anyone that you want, right? And thank you,
yes.
Mudit. Thank you, Lambda Test, for the opportunity. It's been great to be a partner, and I look forward to further partnership. And everybody, all the very best in your testing journey, quality engineering journey. Thank you all.
Thank you, Mahesh, sir. It has been an honor.